Welcome you all to the second lecture in Fourier series. In the first lecture, we considered a few examples where the given function f of x was even. So when the given function f of x was even, Bn was 0. Now here in this lecture, we should consider a few examples where the given function f of x is odd. And when the given function f of x is odd, then a0 and an become 0. So we only need to find Bn. So if the given function f of x is odd, then you have a0 equal to 0 and an also equal to 0. So we only need to find Bn. So both a0 and an are 0. So this is 0 and this also is 0. So let's take an example. Find the Fourier series of the given function f of x equals pi minus x by 2 in the interval 0 to 2 pi, and hence deduce this relation. Now in the previous lecture we have observed that if the given function f of x is continuous between 0 and 2 pi, then we have to put x equal to 2 pi minus x and observe the result. Right? Now if f of 2 pi minus x equals f of x, then it is even. If it is not, then it becomes odd. So let us see what happens. So you have pi minus, so wherever x is there, I put 2 pi minus x by 2. So which is pi minus 2 pi plus x by 2. So you get minus pi plus x by 2. Right? So if I take minus sign common, so I get pi minus x by 2, which is nothing but the negative of f of x. So this is minus f of x. So if f of 2 pi minus x equals minus f of x, then the given function f of x is odd. So therefore a0 is 0, an is 0, and we need to find Bn. So what is Bn? Bn equals 2 by pi, 0 to pi, f of x sine nx dx. So this is 2 by pi, 0 to pi. What is f of x? It is pi minus x by 2 sine nx dx. So 2 and 2 gets cancelled. So this is 1 by pi. So pi minus x is the first function, sine nx is the second function. So your first function into integral of the second function. So integral of the second function is minus cos nx by n within the limit 0 to pi minus integral of the second function, which is minus cos nx by n into differential of the first function, which is minus 1 dx. Right? Because differential of minus x is minus 1. So you have 1, 2, 3 minus signs. So therefore this becomes minus itself. So this is equal to 1 by pi. So I have a minus sign here. Let me take this minus sign outside. When x is pi, pi minus pi is 0, minus x is 0. So you get pi minus 0 into cos 0. Cos 0 is 1 by n. Now you have 3 minus sign here, so it is minus 1 by n integral cos nx. Integral cos nx is sine nx by n within the limit 0 to pi. So here observe, when x is pi, you get sine n pi, which is 0, and when x is equal to 0, you have sine 0, which is 0. So this term becomes equal to 0. So this is 0 here. So here what do we get? Minus into minus is plus, right? So you have pi by n and you have 1 by pi here. So pi gets cancelled, so you get 1 by n. So Bn is equal to 1 by n. So you have Bn is equal to 1 by n. So therefore f of x equals summation n equals 1 to infinity Bn sine nx, which is equal to summation n equals 1 to infinity, Bn is 1 by n sine nx. Now we have to deduce this relation, right? So what do we do? Now this is equal to f of x. What is f of x? Pi minus x by 2 equals summation n equals 1 to infinity 1 by n sine nx. Now let x be equal to pi by 2. So when I put x equal to pi by 2, I get pi minus pi by 2 divided by 2 equals summation n equals 1 to infinity 1 by n sine n pi by 2. So this is pi by 2 by 2, which is pi by 4, equals, when n is equal to 1, I get 1 by 1 into sine pi by 2 plus 1 by 2 sine pi plus 1 by 3 sine 3 pi by 2 plus 1 by 4 sine 4 pi by 2, and so on. So what do we observe? So sine pi by 2 is 1, right? So you have pi by 4 equals 1. And what about this term? Sine pi is 0 plus 1 by 3. So sine 3 pi by 2 is minus 1. So it is minus 1 by 3 plus 1 by 4 sine 2 pi. Sine 2 pi is 0. So we get the next term would be 1 by 5 sine 5 pi by 2. So plus 1 by 5. Sine 5 pi by 2 is sine pi by 2 itself, which is into 1. So this goes on repeating, plus and minus, right? So the even number of terms, that is the second term, fourth term, and so on, they are all 0. Whereas the odd number of terms keep alternating. So it is plus minus plus minus. So therefore pi by 4 equals 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus 1 by 9 minus 1 by 11, and so on. So in this lecture we have considered a given function f of x where the function was odd. And in the first lecture we considered f of x where the function was even. So in the next lecture let us consider a few functions f of x such that f of minus x is neither equal to minus f of x and f of minus x is neither equal to f of x. Then what happens in such cases? So we shall see that in the next lecture. Do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads, and thanks for watching.